It's actually, if you look at the Infinity, I mean, the title was Wi-Fi 0. I think that's what you would have all seen, back to basics. We discussed it, I think, a couple of weeks ago. But then my colleague suggested that since everyone's talking about 6 and 7, or at least 6 got the axe and 7 tries to be. So we decided we'll go for Wi-Fi 8. It also looks like infinity. So the theme of my talk, I suppose, is be more, do less. I'm certainly not qualified. I don't belong to any alliance, clubs, members. I certainly am less certified, qualified than probably all of the members of the audience here. You will find out soon. Flashback. I think good movies, there's always flashbacks, right? So nature proposed, I accepted, and the rest, as they say, is my story. It's true. I'm going to pause on it a little while. I thought it was funny, but I also like the fact that we were supposed to plant trees. Every speaker gets to plant 1 tree or something like that. I get 1 too. Wonderful. I moved here about 15 years ago. It still pretty much remains the same. This is in Kodaikanal. Yeah. This is my workspace. I need to set the context right because I think we started with Wi-Fi 8, Wi-Fi Infinity, whatever, and then, Wi-Fi 0. Hopefully it'll all make sense by the end. For me, the internet comes not from the cat, but you see that small ridge behind, I have a tower there. Okay. And yes, I use Wi-Fi. So this is the crux of it. The crux of it is after, I think Wi-Fi has been around for about 25 years now. Maybe I'm wrong. It was not designed for long range. In fact, I think all the standards and restrictions, and I suppose some of your organizations made sure that we don't use it for long range. That, outdoors can't be used indoors, indoors can't be used outdoors, and you have to stick to 36 dBm and, all the fancy stuff. It's really sad because I'll tell you why. I'm a big fan of Wi-Fi because it actually allowed me to connect to the internet from, you just saw the God-forsaken country, I'm sure all of you will recognize that the standards are restrictive. They don't let me do things, okay? The standards are restrictive. They don't let me do things. So what things do I want to do? What I needed and what I still need is something very simple. I just want to send IP packets on one side, and I want to receive IP packets on the other side. That's it. Nothing more, nothing less. And if the weather conditions, because this is 2.4 gigahertz and it absorbs water, so if the weather conditions are such, it's okay, it's not a problem. We live with that. But the standards don't let me do stuff, and the implementation is even much more worse. And what I have seen over, I think there was a Linksys router, WRT54 or something like that, which allowed Open WRT to run on it. So we started, lots of people started experimenting with it to the point where today most of the routers out there use Open WRT or some variant of it. And the industry has become what I would say intentionally complex. Let me re-emphasize that, intentionally complex. And my reaction to that is, I suppose, the last point. Why Wi-Fi is, I believe the future is very simple. It's just an economy of scale. I think we heard before there are probably 40 billion Wi-Fi devices, and if you look at any other technology, whether it's 5G, 2G, 3G, HAN-G, whatever technology, you will find that the number of devices that have that technology, so to speak, is extremely small. It's probably by a factor of 1:100 or something like that. I don't work for any organization, so I can throw any numbers around and I won't get sued. And even if I do have a few good friends who can get me out of trouble. Probably more friends who can get me in trouble, but at least, So I want to re-emphasize that Wi-Fi, and it looks like O, but it's actually 0. It's meant to be 0. Wi-Fi 0 is kind of the term we came up with. The idea is we can do so much more by doing so much less. If all we did, if all Wi-Fi did, if all it did was just transmit IP packets from one point to another, believe me, pretty much all the applications that were discussed just before, they would be done very trivially, So in my case, because I still, I have to maintain my own network to get internet. And to kind of put things in perspective, this hotel has Wi-Fi, and I think Srikanth mentioned that they would share the Wi-Fi password with me or whatever. My colleague, Dr. Venkatesh here, he did a test. He did the speed test or whatever on the hotel's Wi-Fi. He got speeds of some 500 kilobits per second or something like that. Right, Venkatesh? Yes. And I parallelly tried my 4G connection, and I'm sure all of you would say that I got more speeds, right? I got some 2-3 Mbps. Now, to the same point, same software, we are doing speedtest.net or fast.com or whatever that is. And in terms of density, it's pretty much the same. Same number of people doing Wi-Fi, same number of people doing, 3G, 4G, whatever G, right? So why, how can we, so the thing for me is fixed access wireless, and if we just stuck to the point of transmitting IP packets, we will be that much more efficient. I have not seen enterprise networks, but I've heard horror stories where probably 50% of the traffic is management frames. Why? It serves no purpose. So we just came up with a simple protocol. The protocol is there is an owner who broadcasts capabilities. I have all these channels free. You want to connect to me, you can connect to the internet, or I'll transfer your IP packets wherever my Ethernet sends out. And then there is a simple, members can scan the a known location, find out what capabilities are available, and join that. And the scheduling, I think all the technical folks here likes the keyword scheduling. How do we schedule things? How do we make sure everything is fair? How do we make sure the transmitter doesn't take up all the stuff? I think one of the nice things we need to look at is in this conference, for example, right now I'm talking, Srikanth did the scheduling, I'm talking and everyone's listening. It's a cooperative model. This works. Why can't this be done with IP packets and wireless networks? It is that simple. If we go back to the basics and we look at what it is that we are trying to achieve, and if everything that we send is just IP packets, which it is just that, how many layers of abstraction you need to go through before you get to that. If you remove all those layers of abstraction, you're going to be much more efficient, and you're going to get speeds that are actually usable. So it's not just talk. We actually have something, we have, it's a favorite subject of mine. I think probably around 6 or 7 years ago, I was invited by Srikanth to another conference. And I think I took a dig at the government of India at that point. Maybe time has tamed me, but we decided to work with them this time. So BharatNet is an extremely impressive initiative. They have actually laid down fiber in about almost 200,000 villages. I can attest to it because I do live in a village, so I know there is fiber that's come there. Or at least they dig the roads and do all the fancy stuff. Okay. And the government of India has decided to extend it to 700,000 villages. It will happen. That's one good thing about India is that when the government decides on something, it happens. And whether it happens in 5 years or 10 years, really doesn't make too much difference. But what is the problem with BharatNet? In fact, I think 6-7 years ago when I was a member of the audience and I asked the question, the government said, we don't have any money to provide internet. So then I took a dig at them by saying that it's only the cost of the backbone bandwidth, it's nothing else. So to say that we can't provide, we don't have last mile connectivity, that is the real problem. So we have fibers in all the 200,000 villages, but these fibers are dark. Dark not as insecure or anything like that, they're just unused. So we have this infrastructure. The real problem there becomes last mile connectivity, which obviously, the 4G guys have taken over and they've started providing it, and people today are using, 4G connectivity in villages. The problem with 4G is it is limited in spectrum. Let me not get into 4G, 3G, 5G and stuff like that. So what we have been working on is essentially to solve the last mile wireless problem for BharatNet. And our model is extremely simple. We use our protocol. Just like you have satellite dish TVs at homes, we have an external dish, which I don't know if it's going to be certified, but it will work. It's going to be connected to the Gram Panchayat office with the tower. And our target is 50 Mbps, maximum distance of 5 kilometers, and 100 homes per fiber point. Now, I was warned by some of my colleagues that I should not mention how much it costs or whatever, but we are setting a target price of 5,000 rupees for both sides. I need to emphasize that. Both sides, 5,000 rupees, that's what we're targeting. So then we can enable real 50 Mbps, not the, promised gigabit. I think 6 promised some 3.5 gigabits per second speed or whatever that is. We want to do 100 simultaneous homes with 50 Mbps each. Now, I want to emphasize what 50 Mbps actually means. Some of you may know me from, from my past avatar or whatever, but roughly about 25 years ago, we built same group. We built video conferencing that worked over the internet. And when I say 25 years ago, yes, it was in 97 and 98. We built our own codecs, audio, video, networking, things like that. At that time too, there was a standard called 323. It didn't work. It was way more complex. If you wanted to get a copy of the standard, it was going to cost you $200,000 in 1997. Okay. So we did video conferencing that worked on 35 kilobits per second. It worked. Obviously, I was not able to sell it, so the technology never took off. And then I moved on to other more interesting things. Then, finally, I ended up where I live these days. The trick is 50 Mbps of good connection in villages will change lives. It will really change lives. I can't emphasize that enough. I still, I have a connection. On a good day, I probably get 10, 15 Mbps or whatever. But it works. It works that it allows me the freedom to live where I do and interact with stay connected with the rest of the world and do the things that I do. So essentially, Wi-Fi0 aspires to be an open protocol. I try to be a little clever, I suppose. It's not a standard, it's just a protocol. And it will let you do these things. So if you get lost in the forest, yes, I've had friends who come to stay with me and they did get lost in the forest. And I had to call all my friends, and yeah, it was an adventure I will share with some of you during lunchtime if you ask me. Classic example, if I'm lost in the forest, why can't I send a SOS beacon using Wi-Fi? If all it did was just transmit IP packets, it will work. And if I have 2 other devices that are IP, Wi-Fi0 enabled, so to speak, they can receive these packets, they can do triangulation and figure out exactly where you are. I think there is some, in the slides, I think I saw some standard for location or something like that. During disasters, now this is real, this is a real important thing. During disasters, we had tsunamis and all that. The entire infrastructure collapses. Why can't we use Wi-Fi then? For internal communication, why can't I stream a video from wherever it is to, why do I need IoT? Why do I need some corporation, walled garden corporation, sitting in Silicon Valley deciding whether my video feed needs to go to that device or not? It's not needed. Why can't the village kids use Wi-Fi to broadcast, have their own radio station? Now, some of you may say security. I would warn you in advance because some of my code is in Linux and it's in SSH, so I can talk about it as much, as well. Okay. There are a lot of applications that we haven't thought of that will be possible if we made it simpler, not more complicated. If we made the standards simpler. If the standard fits in one page, everyone will understand it. It reminds me of something a long time ago about, again, 25, 30 years ago, there was a debate between 2 technologies. One was called ATM, asynchronous transfer mode, and the other one was called TCP/IP. I came back to India because I bet it on TCP/IP. The only difference between those 2 technologies was what was called QoS, or quality of service. So the rest, as they say, is history. If we simplify things, we can do a lot more. So I have my colleague, Dr. Venkatesh here. And we have Dr. Devendra Jalihal. He's in IIT Madras, and that's me. We do have a few more people in our group, and in terms of digital wireless communications, I can assure you we know what we're doing. And so does the government of India also believes in what we are doing. So that's pretty much it, folks. It's one of my favorite quotes. Simplicity is the ultimate sophistication. So if you have any questions.
Actually, CDOT has a similar program based on Wi-Fi for connecting the villages, similar to the one what you are saying. So, and also another point, data point is IIT Bombay did an experiment to extend the range of Wi-Fi over like 10, 12 kilometers, just by fiddling with the shifts period and other stuff. So, what is it different that what you have done? I mean, when your custom protocol, you have taken completely out of Wi-Fi model, or it's just something you have modified the Wi-Fi?
Okay, what we did was very simple. We used the MAC layer, because obviously they will not let us work with the PHY layer. Or to be very specific, I'm quite sure there are very few people inside these organizations who even understand how the bits preamble and all. Okay, so we worked at the MAC layer. So we try to work with the restrictive device drivers that are available. And essentially what we did was we transmit IP packets on one direction, and we just listen for IP packets on the other direction. And in terms of encryption, we do have a simple protocol. There is something called noise 4. I don't know if you're familiar with it. But we used a simple protocol where all packets are encrypted all the time. And you don't need any central servers or anything like that. You generate keys. It does require a configuration where initially you set which are the peers, the keys of the peers that you trust. And once you configure it that way, it will start accepting packets with that encrypted keys. So we have built this on top of existing Wi-Fi solutions.
So very nice talk. So I had this question. So does that mean that you have to create your own hardware?
No. Hardware is very expensive and it's extremely political. So we used existing chipsets which have good Linux support. And yes, we use Qualcomm chipsets.
And you have antennas to extend the range, or like how? So you're saying that you are setting up the kind of base station kind of setup on the Gram Panchayat for extending the range. So how do you extend the range?
The range is actually a factor of power. It's just like a torchlight. The more power you give, the more it's going to radiate. Wi-Fi long range with 36 dB, it can go for even 100 kilometers.
I see. And so the client devices also are like smartphones or laptops, so they...
The client device, okay, what we have done is we have focused only on the backhaul problem.
Okay.
So we will have like a, just like you see satellite TV, for example, you have a dish that's mounted on top of your house. We will have something equal, that's a directional antenna, that's pointed to the closest tower, and it just transmits IP packets.
Yeah, any study on the height of the antennas while deploying?
That actually varies in the field.
Just
in the sense that, for example, I live in an altitude of about 5,000 meters, not 5,000, sorry, 2,000 meters. So it depends. You do have to manually, the tower has to be at a highest point, and then all the clients that are connected are at a lower point at an angle. The antennas are kind of pointed towards that.
Okay, any CSMA versus TDMA study, or like you maybe do not?
Well, it is, without getting too technical, it's what I would call cooperative sharing of the spectrum.
Yeah, sorry, we'll have to close this. So thanks, Karthik.